We are on page 6 and we are going to be talking about mechanical and electromagnetic waves. Now, so far we've already discussed that there are two main types of waves, transverse waves and longitudinal waves. What we are going to talk about today are not another two types. They are simply a description of how the wave gets from one point to another. So, mechanical and electromagnetic waves. A mechanical wave is a wave which is produced by a disturbance and is not capable of transmitting its energy through a vacuum. We've already discussed and talked about a type of wave that can travel through a vacuum. Can you remember what this type of energy is, what this type of wave is? We will talk about it later on in this lesson. Mechanical waves require a medium in order to transport their energy from one location to another. So the previous sentence is telling us that it is not capable of transmitting energy through a vacuum. And therefore, the opposite of not being able to travel through a vacuum is that for a mechanical wave to travel, it requires a medium. It requires something to travel on. Alright, the word medium here is not saying that they cannot be large or small, they have to be medium. It is not that type of medium. It is more referring to a way by which it is being transmitted. That is what the word medium means in this case. So mechanical waves require a medium in order to transport their energy from one location to another. Slinky waves, water waves, and sound waves are examples of mechanical waves, meaning each requires some medium in order to exist. A slinky wave requires the coils of the slinky. Without a slinky, I cannot create a slinky wave. It might seem a bit obvious, but that is the description of what a mechanical wave is. If I do not have a slinky, there cannot be any slinky waves. Similarly, a water wave requires the water. I cannot get a water wave in the air. I have to have, water, okay, for the wave to be transmitted. A stadium wave, sometimes also referred to as a Mexican wave, requires fans in a stadium. For those of you not familiar with what a Mexican wave is, what you're seeing now is what a Mexican wave is. It is when spectators during a sporting event, or generally during a sporting event, stand up in succession and they make it look like a wave. Okay, and as you can see, it would go around the stadium and it creates a very interesting effect. It's not a wave as such, like we said about sound or water waves, okay, but we're using it as an example of what a wave is. And finally, a jump rope wave requires a jump rope. That would be similar to what we're seeing here. Right? The athlete is alternating his hands, creating waves in his ropes. Okay, this is a very effective method of training because the rope you are seeing there would be rather heavy. So it is a good exercise for your arms. So mechanical waves can be either transverse or longitudinal waves, as explained before. Mechanical waves are not another type, along with transverse and longitudinal, because both transverse waves and longitudinal waves can be mechanical waves. Alright, so something can be a transverse wave and a mechanical wave, or else something can be a longitudinal wave and also a mechanical wave. Sound, for example, is a longitudinal wave, which is a mechanical wave, and water waves are an example of a transverse wave that is also a mechanical wave. Electromagnetic waves are waves which do not need a medium to transfer their energy. These will be discussed later on in the topic. Have you remembered what type of wave we have mentioned that can pass through a medium? The waves we are referring to are infrared waves. When we were doing heat and when we were doing transmission of heat, we had said that conduction happens mostly in solids because it requires particles vibrating and hitting their neighbors. We said that convection is when heat transfer happens in a liquid or a gas, when the bottom part of a liquid or a gas gets heated and it rises up due to the change in density, and the colder parts of the gas or the liquid come down because they have a larger density and creates that cycle. But then we mentioned radiation. We mentioned heat transfer by radiation. And there we said heat transfer by radiation, while still being able to pass through air, for example, it can travel through a vacuum as well. In fact, it is the way by which heat and light from the sun reach planet Earth. In outer space between Earth and the sun, it is a vacuum. There is no atmosphere, there are no liquids. So for the light waves, as well as the heat waves, the infrared waves, to reach us, they are traveling through a vacuum. Now, both light waves and heat waves belong to the same family of waves, called electromagnetic waves. But, like the note is telling us, we will be discussing in more detail later on in this topic. Okay? All you have to remember at this stage is that electromagnetic waves are not mechanical waves, because they do not need a medium to transfer their energy, and they can pass through a vacuum.